So from this definition, we take our sub-topics. That is clear. And the two thing, I don't do talking alone. If there are questions you need to ask, you ask. So you answer the questions. And since water is involved, this will take us to a subtopic known as sources of what? Water. So what are at least one source of water that we know? Well, okay. Well, rainwater, okay. Okay. What else? Which one source of water do you know? Okay. So I'm going to talk to you. It's not that other water cannot be treated. It can be treated. So we should accept the borehole. So look at the source of water, which is the borehole. And basically, we have two types of borehole. We have the shallow borehole, and the second one is the deep borehole. When we say shallow borehole, we are simply looking at a borehole within a range of, let's say, 1 meter to 20 meter depth. Then from 20 to 200 or 250 meters, referred to as what? Deep borehole. And also, in discussing the borehole, we have two types of pumps. Let me use three for this class. Well, let's reserve it to two. It's still two. We have one that's referred to as the surface pump. That's what the plumber will call it. But in engineering, it is called centrifugal. Centrifugal pump. Then also we have the submersible pump. Now, from there, electrical as well, we have two types. On electrical aspects, we have two types. We have the single phase pump, and we have the three phase pump. Now, let's look at the surface pump. Can I clean it? For the surface pump, we have two sides for the pump. Let's do a sketch. Let's assume these are centrifugal pump. We have now, this side of the pump is the electrical side, which is referred to as the motor. While this side is the mechanical side, which is also referred to as the pump itself.
So we're getting complaints online that they can't hear you properly. So
Like I said, my voice is not
okay. Let's.
I started already. I can continue. You have thumbs up.
Yes, sir.
I give you thumbs up. So I said we have the electrical side and we also have the mechanical side. And the electrical side is referred to as the motor. Mechanical side is actually have the pump. Now, inside the pump, this is your casing. There are coils that are wound around it. You have the coil. Then this is called the stator. STATO. Then you have the what? The fan. On top of it here, you have the panel. You have the panel where you can do your connection. Inside for a single phase pump, inside of this panel, you have the capacitor. Now, most times you saw that you buy a new pump and maybe after 1 week or 2 weeks, the initial pressure from the pump drops and there's nothing wrong with the coil, there's nothing wrong with the pump side. All you need to do if you experience such situation is to replace the capacitor inside the panel. It means the capacitor is weak. The same applies to your ceiling fan. That it's quite at times that the speed of your ceiling fan will have dropped. All you need to do is the ceiling fan has its own capacitor. Change the capacitor. There's one on the ceiling fan itself and there's one on the control. Once you change this capacitor, the speed of the fan will increase. It applies to pumps as well. When you discover that the pressure is low for a single phase pump, it could be as a result of the capacitor that it is weak. Now, for the motor side, by this side, the middle between the pump and between the motor and the pump, you have a seal that is referred to as the mechanical seal. Or the plumbers will call it water seal. Inside of it, you have the impeller. And also have a casing. Then this aspect is called the suction side of the pump, while the top is the discharge side of the pump. Are we communicating? Okay. I have to quickly explain this because we'll come back to the pump. But let's look at the surface and the shallow borehole using the surface pump. Now, let's do a sketch. Let's assume these are. Okay. Let's assume this is the ground. Now, this pipe you see that is in between the ground is referred as your casing. Now, this and the perforated pipe is referred as the screen. You will see most times when you drill the borehole, they will put, they pour gravel. That is referred to as gravel packing. The pipe you run to take water from the borehole, the pipe is referred to as your riser pipe. If you are going to be using a surface pump to take water from the borehole, you will need to introduce at the tip of the pipe here what is referred to as the foot valve. FOOT. The function of the foot valve is to aid in priming. What I mean by in priming is this. Normally, you need water to be retained along the riser pipe for your surface pump to be able to suck water. Because if there's no water retained in this riser pipe, most times what you do is that on your T, you open it and you pour water before the impeller can actually suck the water. So to avoid repeating this process over and over again, that is why you introduce a foot valve. So the foot valve is single, one directional flow. It doesn't allow water to flow out. So water is retained here. The foot valve is a bit similar to what we refer to as a no-return valve. So most times I advise my clients that after you've introduced your foot valve, at this place also introduce your no-return valve. In case if the foot valve fails, the no-return valve will stand as a stopgap. It's a one-directional valve. It allows water to flow in one direction. So sorry. Any questions so far? Ask your questions. Ask questions. Ask questions now. So it's not just the only a shallow borehole that we use surface pump. You can actually use the submersible pump. For the submersible pump, you don't require any foot valve because on the submersible pump itself, it has its own foot valve. So the submersible pump will try inside water. We'll just put inside water and start pumping. But for shallow borehole, you can only get submersible pump in a range of 0.5 to 1 horsepower, max 1.5 horsepower to work effectively. Shallow, yeah. Question. Okay. Of supplying. Okay, I will answer a question. You see, normally when you are through drilling your borehole, there's what is referred to as the read test. This test is done to actually determine the volume of water that you can get from a borehole. So the way it's done is this: you have a pump inside of it, and on the riser pipe like this, you introduce what is referred to as the pressure gauge. So if the gauge, for instance, is on 5 bar when you started pumping water from the borehole, after 1 hour, after every 1 hour, you go back and check. If that gauge is still on 5 bar for 1 hour, another 1 hour, for 6 hours, it does not shake from 5 bar. It means the yield, like the water you have in this well, is okay, it will serve. But if after 1 hour, it leaves the 5 bar, it moves from 5 bar to 3 bar, that means your borehole yield is not enough. Now, with respect to your question, if it's a high-rise building, if the shallow borehole is going to serve, it depends on the number of people in that building and also the yield that you're getting from a shallow borehole. There are calculations to actually determine the volume of water that people in that building will consume. Standard practice is that sometimes we should say 100 liters of water, that's consumption, 100 liters of water per day per person. While some will tell you 150 liters of water per day per person. So for instance, if you want to determine a 3-bedroom flat, you assume that 4 or 5 people will stay in that 3-bedroom flat. So if you are saying 100 liters of water we consume by one person per day per person, one person per day, that means 5 people will consume how many liters? 500 liters. So we will assume that 500 liters is what they will consume per day. Then you allow for at least 25% addition. That is water to wash maybe the car, to wash flowers and stuff like that. So with this, you go to determine the size of your tank, your surface tank. The size of surface tank cannot be the same size with your overhead tank. We'll get there. Let's just continue. Now, this water cannot be sent into the building like that, because like we said, the water is meant for use. So if water is meant for use, then we need to treat the water, isn't it? So let's look at treatment. We're looking at 2 types of water. 2 types. Two types of treatments. We look at 1, the chemical type, using chemicals to treat water. Then 2, we look at reverse osmosis. Now, before you can determine or before you can treat any water, you need to take the sample of the water to the lab for analysis. And what the lab guy will do, the first analysis they'll do the physical analysis. Physical analysis of the water. Then 2, they'll do chemical. Then 3, biological. For physical, what they're looking for, they look at the color of the water. 2, does the water smell? Does it have odor? 3, they look at color, odor, then temperature. 4, taste. Yeah, God bless you. Then for the chemical, we look at the iron 2 oxide, iron 3 oxide. We look at if it has a salt, the salt component in the water. That's the salinity, sorry. Then you look at the carbon, you look at if it has ammonia, you look at if it has just the, the elements, chemical elements in the water. Then biological, you know biological now, if it has what? It has bacteria. E. coli, or E. coli, E. coli. This they will check. Then they will check the level of all this inside the water. With the level, the parameters that the man has gotten, he will give it to the engineer. And with this, the engineer will need to do a design that will work with the water. Are we communicating? So now let's look at chemical. I haven't gotten all the parameters that is inside the water that you need to take care of. There's one major thing we need to look at. It's called the pH level. Don't forget, those days in secondary school, primary school, and then they will tell you that we have 2 types of water, isn't it? They'll tell you, hard water, What kind of person is the second one? Salt. But I used to tell people that, is it true we have, for me, I believe we have permanent hard water and hard water. But people say salt water. The pH level is simply a meter. We have from year to year to be what? 14. Then the middle is 7. When it's from 0 to 7, we say is what? Acidic. From 7 to 14, we say is alkaline or basic. Anytime you choose to use is the same. Now, the new standard for clean water says your water was between 6.5 to 8.5. If you can get 7, perfect, 7 is neutral. But they still allow between 6.5 and what? 8.5. Also, water, we have chemicals that we use to treat water, isn't it? Am I too fast? I don't think so. Because the hand that is much. Chemicals that we use to treat water. We have 1. We have chlorine. We have 2. What is called lime. Then we have 3. Soda ash. 4. Alum. The one they call aluminum sulfate. Now, chlorine is actually used to do what? To kill bacteria or germs inside the water. It also improves the color of the water. And also even the taste. One thing you need to know is this. If your pH, the pH level of the water, if it's less than 5, chlorine will not react in the water. It's just the chlorine. No reaction will take place. If your pH is less than 5. Then, if the same pH is greater than 8.5, chlorine will not be effective. So, you need to bring the pH of the water to a acceptable limit before chlorine can be effective in the water. And how do you do that? Now, once your pH is above, so it's below 6.5, you need sugar ash to increase it. You need to inject sugar ash to increase it. Then if it's above 8.5, you need lime to bring it back. Did you get that? If it is below, you need sugar ash. If it's above, you need what?
If it is below 6.5, you need soda
to take it up. Then if it's above 8.5, you need lime to bring it up. Are we communicating here? I hope you are understanding it. Then alum is a coagulant. What it does is that if you have, for instance, water that has mud in it, when you throw your alum inside the water, it will bring the old mud, bond them together, push it down. So you have clean water on the surface, the dirty water will be at the bottom. It's a coagulant, it will coagulate everything and bring it down. That's the function of the alum.
Like if you don't have like sediment,
To take it down. Pull those dirt down. You're going on road trip now, isn't it? You go on road trip, you visit some of the water plants. So we'll demonstrate that for you. The additional plants. Okay. We still continue with our sketch. We are moving very fast. So this is riser pipe. This is our pump. Now, this tank, the first tank you have your water entering into is referred to as the aeration tank. I'm not going to tell us what is aeration. Yeah, that's good. It actually assists in oxidation, which is the breaking down of iron molecules towards smaller molecules. But in terms of aeration, it helps in expelling the odor that you have in the water. When you allow her to beat against the water, so some boreholes are terrible. When you perceive the odor, you need to drink. Once this takes place, it will expel the odor to a certain extent. Then it also assists in bringing down the iron content inside the water. It's called that the iron will settle at the base, then clean water will be at the top. Now, this that I've just done here is called the aerator. And we have 3 types of aerator. We have one, the sprinkler system. 2, cascade. The third one, I will explain. The sprinkler system, most times when you go to a treatment plant, it's called that they used shower hose. All they're trying to do is that the water should not just come in pressure and pour like that. They try to break it aside to fall down like sprinkle, shower. If they don't use shower hose, at times they will use pipe and they'll perforate the pipe. So that hair will just react with it. Then also for cascade, you see that on the aeration tank, you have something constructed like step.
on it or inside it?
No, on it like this. This is not connected. If this is a pipe from the borehole, it's not connected here. So water will flow, come like this, come like this, come like this. Apart from trying to achieve aeration, the other thing I try to achieve again is what we refer to as detention time. Sometimes people tell you retention time. Now, detention time is the time the chemical that is injected into water will react with the chemical to break down whatever things that you need to eliminate from the water. Whether your iron content, whether your salinity, whether your TDS, total dissolved solid, you need enough. You need to buy time so that the chemical can react effectively with the water to expel all those things, the odor, the taste, and the rest of it. Are we communicating? Now, also, if you look at the aeration tank, when you get to the piston, you have by the side here some use 2, some use 3, all this a tank where you put chemicals. They refer to as a chemical tank. On top of it, you have a pump called the dosing pump. DOSING. This dosing pump actually injects the chemical, whether the chlorine, whether the alum, whether the soda ash, whether the lime, into the aeration system. One mistake that people make is that after having the dosing pump, they will ignore the stirrer. SITRER. The stirrer is very, very important. Okay, you're sleeping. This is like you've been working since morning.
So that pump, dosing pump.
Dosing pump, DOSING. The stirrer, what the stirrer does is this. You know, for instance, chlorine. Chlorine, you have two types of chlorine, or three types of chlorine. You have one, the tablet form. Two, the powder form. Then three, the liquid form. Chlorine comes in three types: powder, liquid, and tablets. Now, if the chemist has advised that, for instance, you require 5 grams of chlorine to liberate 10,000 liters of water. And you are using powder chlorine. By the time you take this powder chlorine, the 5 grams of it, and you pour it inside a chemical tank, and you don't have a stirrer, what will happen? So that it will settle at the bottom. So instead of using the 5 grams that has been, given to you to liberate 10,000 liters of water, maybe at the top of it you are having just 2 grams or 1 gram. The remaining grams are at the bottom of this thing. So the function of the stirrer is actually to allow for homogeneous mix. So that the 5 grams that have been advised that you use to liberate 10,000, you're actually using that 5 grams. You are injecting it into the water to liberate the 10,000 liters. Are we communicating? Because there's some water facility you go to, you just see just a dosing system. And the people will tell you that my water is not clean, my water is not clean. How will your water be clean? When they've told you use 5 grams of chlorine to liberate 10,000, and you are saying that it's 5 grams I'm using now. No, you're not using 5 grams because the other one is settled at the bottom of the chemical tank. So the 5 grams is actually working. Are we communicating? Question. Me, I'll ask question. Yeah.
More.
I'm with you.
And that tension time, I didn't get.
So it's the time you allow for the chemical that you inject in the water to react effectively with the water.
But the chemical from the dosing
Yes.
tank.
Yeah, you put chemical in the dosing tank.
During the process of going to the aeration tank,
Yeah.
that's where the settlements, like reaction.
Take place, yes. You are injecting chemical into the water. This dosing pump, there's a hose on it that you connect inside the aeration tank. So it will be injecting chemicals like droplets inside the water. So the time this chemical is injected into this water and it reacts with the water, it's actually what we refer to as detention or retention time.
So can you comment on that?
Aeration. Explain aeration to him.
Like that,
Explain to him. Explain one to him, just one.
Okay, just said that
Explain the sprinkler system to him.
the sprinkler system is kind of it comes like in droplets, not very large, but it comes in droplets.
Okay. Explain to him, Kenneth.
just like a shower. I don't know if you know your shower. Once you put up the water to come up the gas to bring it and bring it.
So the hair around the environment can react, you can beat against that water to break down the whatever, whether the iron content or the shower or the just to expel it. Because some water facility, instead of using natural hair, you equally use a air compressor. It's the same thing as aeration.
Using air compressor and natural air,
So I said before you treat your water, you take your water to the lab, you do analysis. It depends on what the lab guy has advised you. The degree of the ion component inside the water will determine the system you will choose. Any other question? Ask questions. It's not as when I've left the class, you say, that man, I wanted to ask him this question. Okay, let's continue. There are no questions. That's wrong.
Yes, I know mentioned
Mechanical type, you use your compressors and the blower. Your air compressor and blower. For air compressor, it's simpler. You just pipe it into the water. But for the blower, then you now need to introduce nozzles. Introduce nozzles to just introduce that, inject the air into the water. Now, from this point, this side is the sedimentation side. This aspect is called the coagulation. Then the third one is the filtration side. Now, I say something that your chlorine will not react if your pH level is less than 5. So now that if you increase your pH level from 5 to the standard 6.5 to 8.5, which chemical do you inject? This man, you want to open your textbook and check. Soda ash. Good. Now, soda ash, because take for instance, if I'm going to use these 3 chemicals to treat water and the pH is less than 5, we need to inject that soda ash, we connect it to somewhere here on the riser so that it will react to the water, take up the pH to 6.5 or something close to 8.5 before we now introduce all these other chemicals. Yeah. So when you introduce chemical here, if you are introducing alum, I told you alum is a coagulant. What will happen? Coagulation will take place. It will pull down every other thing that is kept here, pull it down. So this place where you have here is at least 40 to 50% clean water. Are you getting it? Now, after that, we introduce a pump here. From this pump, we have what is referred to as the filter vessel. Filter vessel. Now, inside the filter vessel, what we normally do is that we load the filter vessel with what we refer to as media. I'm going to cut this filter vessel now and I'm going to dissect it to show you what is inside the filter vessel, how it looks like. Are we communicating? Can I clean the board? Can I clean the board?
Yes.
Okay, let's assume this is our filter vessel. This is what it looks like anyway. Just to sketch. Inside the filter vessel, there's a plate. The plate is actually perforated. Now, there's something like a filter also, but we call that thing the screen as well. Some people will tell you that it's nozzle. But the screen, it does, the filtration. Now, on top of it, there's supposed to be a pressure valve, a pressure gauge. The function of the pressure gauge, a lot of people don't know. They think it's just for fancy. It's not. This pressure gauge is actually to determine when this filter is due for recharging. What I mean by when the filter is due for recharging, I told you that inside the filter we have media. Those media actually does the work of treating the water. But after some time, it will become weak, expired. So you need to recharge it. Instead of saying you need to remove it and load it, the term we use is that you need to recharge the filter. Are we communicating? Now, the first filter, what you have actually have inside the first filter, which is the media. The first one that will be at the bottom here is what we call the big stone, which is gravel. Not granite, gravel. Use a local gravel, but it's washed, it's treated. Now, the second one that follow it is the medium size gravel, medium size stone. Then the third is the coarse sand, while the fourth is the smooth sand. Now, on the filter vessel, there's a socket on top like this. When you are loading your media, I told you the first this thing will take the big stone, the second one will take the small stone, the third will take the coarse sand, while the final one will take the medium, the smooth sand. You must allow a space between the final and this socket here, at least a space of 100 mm, which is equal to what? 4 inches. So that the media can breathe, so that you can allow for what is referred to as space for backwashing. Because if you load it to the top, backwashing will be difficult. I'll explain. It's a reverse process. If your flow is from the bottom, oh my, something is okay. If your flow is from the bottom, that's water is coming from the bottom to the top. When you're doing backwashing, it's a reverse process. You are reversing it. The water will now flow from the top to the bottom. Now, this is for the first filter vessel. For the second filter vessel, what you need to do, you put your coarse sand. After your coarse sand, you introduce what is called activated carbon. Now, we have two types of activated carbon. We have carbon from coconut shell, and we have one from coal, that's charcoal. The best type of carbon for treating water is actually the one from the coconut shell, and it's very expensive. What the carbon does is this: it takes care of it, it allows you to get good taste, it will remove color, and it will remove odor. That's what the activated carbon do because of its adsorption process. It will absorb all those things. Odor, taste, and color. Carbon takes care of it. Then also, after that one, you will load the bend. The bend is iron, it removes iron. Then the fourth one, you know what is called the adolite.
Then the top, you just put a smooth sand.
No, I think it's
Then BIRM. Adlyte, AGOLYTE. Then 5, smooth sand. There are some very, very stubborn water that you might need to introduce what is referred to as resin. We have two types of resin. We have the positive resin and the negative resin. It will be on a zone filter vessel, a third filter vessel. That's when the water is very stubborn. Very, very stubborn. But this, the chemist will advise you when to use it. Resin, either the positive resin or negative resin. More. No verse. Testing. I enjoy it when my class, when they ask questions, not when everybody's looking at me, being talking. Make me get tired easily.
Yeah, this is
Actually, carbon does not flow jam now. You need chlorine to take care of the jam, bacteria. To an extent, you still need, because, in a way, chlorine too is harmful. So, with avoid carbon and your sun and rest, you also take the chlorine away from the water. In case your technician has gone to overdose the water, all this will actually assist in reducing the percentage of chlorine inside the water. Yes, if you are using the arrow. If you're using arrow system, use UV. Even after this, it's not chlorine cannot even kill everything. At times, after I've done all this, I still put UV.
How can they test it?
They take it to the lab now. Hard water. Is it stubborn or hard water? What is stubborn water? Oh. Please ask the guy, is it hard water? Or, that different types of water, two types of water, I said, hard water or salt water. Yeah, so please ask what is saying when he says stubborn water. Water very stubborn. Sorry, please tell him I said hard or salt water. I said the chemist will advise you when to use resin based on the analysis. Like I said before, you treat any water, you need to do your water analysis. Analysis will tell you what you require to treat the water. So it's really left for the engineer to do his own design based on the analysis from the lab. And it's the analysis from the lab I actually tell you all these things that are many here that you can use, or that we've mentioned that you can use. To test for hard water, you can actually do your own test at home. Hard water don't lather easily. You pour soap, it won't lather easily. Okay, so we've looked at the filter vessel. So from the filter vessel, you can actually introduce a UV lamp if you're not satisfied with the extent of, bacterial removal from the water. You can choose a UV light. UV light also will, assist in destroying any bacteria that escapes chlorine. UV lamp will take care of it. Then from here now, water is pumped into the radar tank. Then from the radar tank, we can actually pump the water to
the, what's it called? Overhead tank. 40. Then from the overhead tank, it is sent to the buildings. But be that it may, we still have two types of, two ways to transfer water into an estate or into a building. One, we have the gravity type. Then two, we have the booster system or pressure system. This one is the use of the overhead tank, which for me is more preferable because of light. Where there's light and there's no light, as long as you pump it into your overhead tank, water is distributed into the building. But people will say, the pressure from the overhead tank is not okay. It's not true. If your design, for instance, if you have a duplex, normally standard height is from here to 2.7 meter, edging 2.7 meter. So the total height of the duplex cannot be more than 6 meter, or max 6.2. So, and you want to put an overhead tank. If you increase your overhead tank to about 8 meter or 9 meter, the pressure from this that will distribute into the first floor bedroom will be perfect. You're okay. Whether you are using power jet shower, it will work effectively. These days, you just find that people, rent an apartment because they are expatriates. They will tell you, the water from my shower is not, the pressure is low, that they need, high pressure. The facility manager will not even check the integrity of the pipes that you have in the wall. Don't forget also, let me mention here, we have two types of piping system. We have the conduit piping, which this one simply means you bury the pipe in the wall. And we also have surface piping. The surface piping, you just run the pipes on the surface of the wall. So if what you've done is conduit piping, and the expatriate tells you the pressure of the water I'm getting is not high, please increase the pressure. You now go to the market and you buy a booster pump to increase the pressure. Forgetting that for every pipe, it has the maximum pressure it can withstand. If you not put that into consideration and you now use a booster system, for instance, if the maximum pressure of the pipe is 6 bar, and you now use a booster system that is doing 7.5 bar, you start having burst. And that's where you go to most buildings. It's not that the facade of the building, it's bad. The walls are stained and everything. So you need to, you just don't jump into solution because you're trying to please somebody. You need to go back, think about it. I need to know the integrity of the pipe that has been used. Can the pipe withstand this pressure this man is asking before you jump into introduce the booster system? And this also will take us to types of pipes. Types of pipes. Now, number one, we have PVC pipes. So we have 3 PVC pipes. 3, we have multi-layer pipes. 4, we have your galvanized pipe. 5, copper pipe. 6, stainless pipe. 7, concrete pipe. 8, black steel. 'Black steel pipe. Now, who can tell me, show me your PVC? Good. New PVC.
And you have used from 50 up.
TPR. Okay. There's a name for TPR. Who can tell me UPVC? UPVC pipes. Okay, UPVC simply means unplasticized polyethylene chloride. Unplasticized. Then multi-layer pipes actually, have you heard of Enco pipe? Have you heard of rifling? You've not heard of Enco, you've not heard of rifling. Okay.
Okay, I get your different two types.
You said?
Because you know, common is
No, that is not the name, that is the brand name. The name of that pipe actually called multi-layer pipe because they have multi-layer. You have plastic, aluminum, then plastic. This pipe are very, very good because it can withstand up to 16 bar in pressure. You can use it for both hot and cold line. Just the way you can use copper for hot and cold line, you can use stainless pipe for hot and cold line. You can't use PVC is just used for cold water line. PVC is used for waste.
well, is that they are into the proper
Yeah.
So what's that about? 7 feet.
This concrete pipe, galvanized, sorry, concrete, yes, and stainless steel, black steel pipe, black,
So what do you call that say?
concrete. No, those days in waterworks, generally concrete pipe, they used to pipe water. They still use it now. They still use it.
For new facilities, like they are constructing and
No, they can't use it now, but those days they use that. If you want to have maintenance, you still got to look for it to replace any problem.
you said you must lay out.
No, I said these are brand name. The brand name Enco, Rifeng, they are different brand, but they are the actual name for it is, multi-layer pipe. So from here we look at types of fitting. Or size of pipe first. Size of pipes. Now we have two types of measurements. We have the SI unit, and we also have the what? Imperial unit. Now, for size of pipe, any pipe that you see right, your 13 mm pipe is what they refer to as a half inch. Your 19 mm is referred to as the quarter inch. Your 25 mm is referred to as your 1 inch. Your 32 mm is the one they call the inch and quarter pipe. Your 40 mm is the inch and half. Just like that, you know, maths, you can get the others. Are we communicating? Where is this guy? Okay. Then also, let's look at types of fittings and their function.
This is
We have the elbow, and there are two types of elbow, three types of elbow. We have the 45 degree, we have the 90 degree. The 60 degree is not common, but the 45 and 90 they are very common. We have two. We have the T. Three. We have the union connector. 4. We have the adapter. 5. We have nickel. 6. We have socket. 7. We have this one's called the white T. 8. We have plug. 9. Anybody? No, valve is not fitting. Anybody? Why are we going in this class? And is that you've not read the handout or you've not read the...
oh, yeah. After the lecture.
Okay. 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 I almost said everything. They just tell me when I've not said myself. So I will those are sockets. You are seeing that sockets. We've mentioned nickel. We've mentioned adapter. Yeah, we mentioned union. Another one. Okay. Now, yeah, remember. Reduce what they call bushing. So when do we use this? When do we use this? Elbow. Elbow is actually used when you have, if, for instance, I have a wall like this, and I'm running a pipe from here, I have to continue the pipe here. What I will use is an elbow, 90-degree elbow, so I can continue with the piping. That is the function of the elbow. Now, for the T, let's assume this is my dot. I have my WCA. I have my bathtub here. And I have, okay, let's say this is what happens by the WCA. And the pipe is coming from the duct. You know, I want to run the pipe this way. I run it this way as well. I'll use a T. I get this. A T allows you to do three-way connection. Like this, and like this. So why is the T here now? I can use an elbow to continue. And I'll use a T here again.
Are you getting it now?
Then it runs continuously, then I'll use an envelope to it.
That's the function of the T. Are we communicating?
Now, the union connector.
So also, have 4 weeks.
Yeah, we have 4 way T. That's for electrical.
No,
We don't have anything in plumbing.
no, that is mostly for waste.
Plumbing, 4 way.
For waste connection.
If you use 4 way for waste connection, you'll be having blockage. You'll be having blockage, I know what I'm saying. You'll be having blockage. I know what I'm saying, you'll be having blockage. You'll be having blockage. Basically, for waste collection, what you will see most times is white tea. And the white tea will have a sweat wire.
That is the only big fault. There is one that is more than this, and there is one white fault.
I know what you're saying, I've seen it.
So the white fault can.
Don't use it, you have to block it, I'm serious. Don't use it. If the plumber is trained and is certified, but for your local plumbers, you want to go and use that, you have blockage. You have blockage. The union connector is used basically when you have, for instance, this is your washing basin. I want to connect the washing basin, and I need at times to carry out maintenance on the washing basin. You can actually connect the tap of the washing basin. You can use a union connector to connect it. And union connector are basically connected on surface, not for conduit. You cannot do union connector conduit, whether inside the wall or inside the ground. It is wrong. It should be surface. Now, adapter. You know, when we sketched the pump, we said this is your discharge, this is your what? Suction. For you to correct the adapter, if I have a plain pipe and I have this, most times the side of the pump is threaded. So the adapter is like this. This side of it is threaded. This side is plain. So the threaded aspect, we always connect to the threaded aspect. That is, the male will go into the female thread, just like this. This internal thread, external thread, you connect it. But this plain side will require solvent, a gum. So what it does is simply, if you want to connect the thread to the plane, you use an adapter. Are we communicating here? Then the nipple. The nipple is on the both side are what? Threaded. This side is threaded, this side is threaded. Unlike the adapter, you have one threaded side and one plain side. Are we communicating? The socket. The socket will either be, the internal will be threaded, but it's like this. Is that you have the inside, both inside will be plain, or both inside to be what? Threaded. It's actually used to join two pipes together. You can use the socket for conduit and surface. Are we communicating here? Then the white T. The white T, this guy is used in waistline. It's like your T to form 3 branches. The riser pipe for the vertical pipe, the water line is called riser. But for waistline, the vertical pipe is referred to as the stack. Stack. S-T-A-C-K. For waistline. The vertical pipe is referred to as the stack. Then we have the plug. Plug is simply just like you come off your pen. If you are running a pipe, a straight pipe, and you want to terminate this, all you need to do is introduce what? A plug. Then the reducer. If you're running a pipe, for instance, a 1-inch pipe, and this at this point you have
a 3/4 inch pipe, and you want to link the two together. What you introduce here and here is the reducer. This end of the reducer is 1 inch, this other end is 3/4. So you can actually link each of them together. Is it clear? Okay. Then we look at joints. Types of joints. Now we've talked about using solvent. Guys, we're using gum. You have plain pipes and just use your tangent gum, your apple gum to do your what connection, your joining. You have the one that is called the deep brazing. Those are actually for your copper pipe. Then we also have threading. These are some that have the screw fittings. We have thread, both sides. We have the one that you hit it. And that's the one you call the PPR. We also have the welder joint. Welding. That's like your galvanized pipe. Your copper too, you can do welding. Your black steel pipe, you do welding. Then the 6th one. What can help us? The 6th one. What did you study in school? Electrical. You must give us this one. Yes, now. I did electrical as well. Let's see. That is not true. That's not true. It's extreme to you. That's serious. What did you study in school? Mechanical. I did not see this one before.
Some of it are familiar.
Okay. Computer science. This, you don't give me an excuse. No excuse. This man, what did you study? Well, you are trying. Whether you study computer science, whether you study computer engineering, whether you study electrical, FM, it's everything put together. I believe they would have given you the definition of FM. It's everything put together. An FM person is. No, so good. Have you heard of the word? The oxyacetylene.
That's so true.
No, that's not sodium. Oxyacetylene is not sodium, that is brazing. Sodium is actually where you use C-force. Okay, you use C-force and use your oxyacetylene gas as well. Use C-force and use your oxyacetylene gas as well. Use that one in copper pipe too.
Yeah. Because I thought that sodium has covered that.
No. Welding is use your electrode.
That's for my skill.
Use your electrode. So, we mentioned multi-layer pipes. There are some multi-layer pipes that they use the screw type and they use clamping. This man has worked on site.
Because I thought probably it's covered that because copper pipe.
Clamping is different.
Yeah.
You use there's a tool that you use. You put your fittings, then you clamp together. It's different.
Because ankle pipe also works as that place. Yeah, so
No, Enco don't use basin. Enco just have two types: the screw type and the clamping. The basin basically is for copper pipe. Any question? Okay. We are running. Now, let's look at the nomenclature here. We've mentioned that the vertical pipe is what we call the riser pipe, isn't it, for water line? Now, when you have high-rise building of this nature, the pipe that is connected to the dot that runs like this, they are referred to as the branch pipe. Now, for this branch pipe, there's another pipe that supplies the WC, supplies the ocean basin. These ones are referred to as supply pipe. Now, if this supply pipe does supply the tap, this tap, what a supply tap is called draw off point.
And the point of
Yeah, draw off point. Now, this is for high-rise building. But with an estate, where you have buildings like this, the pipe that takes from the overhead tank and that supplies the estate. This pipe is referred as the main. It's called the mains. Then from the mains, you cannot branch into the building, branch pipe.
but those ones are under
Under the ground, yes. Mains. Those are the bigger diameter. Take an estate as 1,000 of operations. The bigger diameter pipe that supplies the estate is called the mains. I'm not writing. It's not that standard they will give you. I'm telling you, what you're saying here is not. I wrote that handout, so I know what I'm saying. Ross, I was wrong, don't be afraid. Yes, ma'am. When she kept calling me, where are you now? Where are you now?
and
Thank you. Okay. Any question? So, we talk about the cold water line. Let's look at what's basically for this, we just look at the water heater. Water heater. We have the instantaneous water heater. The way it works is this: as soon as water, this is the heater, as soon as water passes through it, it becomes hot immediately. Unlike your other boiler that you leave for like 20 to 30 minutes, this one, water passes through it, it becomes hot immediately. As I refer to as the instantaneous, water heater. Now, the other one is the boiler system. You need to be very careful with this one. it has some safety devices around it because the boiler is like a potential bomb. If, for instance, it requires a 6 bar, to be built up, and you allow it to exceed that 6 bar, if the safety device on it is not functioning, if it explodes, everybody in that vicinity is gone. But the advantage of this one to this is this. This one consumes a lot of electricity, power. But this one, since as soon as water gets into comes out, the power consumption, is low. So most times I advise clients to go for this and this. This one most of the days in hotels, where they just put it underground and they'll pipe it around the bedroom. So if you need water, you just call for it and they release for you.
This one is going to store.
The big, I call it as a giant kettle. And they will install it, for instance, if this is there. Exactly. So you call, when you use water, you call for it. They will send to you. But this one is inside your bathroom already. Waste. Now, let's look at waste. What do we call the sewage system of waste? It's by the waste system or sewage system. Now, before we look at the waste system, let's talk about sand, please. We need to get this right. Your WC, water, closets. We have 2 types of WC. We have the pit trap, and we have the air trap. So let me call this guy to show you something. I hope we have. Excuse me. So we can connect it to internet.
Yes.
Okay. Just plot a picture of the pit trap and the air trap WC.
Extra and
Pit trap. Pit trap. The pictures. These are not traps, so you don't put WC. You didn't include WC. Okay, leave it, assume. No. WC.
which one?
Let's look at.
This one.
Yes.
Which traffic line?
Is it this one?
Yes, you can use that one too. So, no, you can even, there's one here. There's one here.
Is that it?
That
Okay, I've opened it.
this one is the edge trap. Now, a lot of people don't know, a lot of plumbers, they don't know. You tell them, buy me WC. You go to the market and you just tell the people selling WC, give me WC. If you have high-rise building, they want to install WC. If you buy this for the first floor, you'll be having an issue. Because this edge trap WC basically is for ground floor. Are you communicating? It's for ground floor. So that when you connect, it's easier for you to connect the trap straight to your IC. The IC is your inspection chamber. But if you buy this for first floor, by the time it's connected to the, when I told you the vertical pipe for, it's called the stack. By the time it's connected to the stack, you start having blockage. Then even the siphon, because instead of trying to flush, you'll be pressing it continuously. That's why it's called that most siphons, after 1 or 2 weeks, it says siphon is faulty, siphon is faulty. Check the WC, if it's the right WC that has been installed in that floor. People don't know there are two different types of WC. They just believe that WC is WC. Can you show the picture?
So we're looking for picture.
It's there, it's there.
So which one would you prefer?
It's actually, this is the P.
Okay.
This is the P. This is the P. You can see the difference. You can see this is P. This one does what? It forms your S. So this one is easier for you. The way it is, it's easier for you to link with the pipe the pipe you're connecting. So to connect to the vertical pipe, which is the stack, unlike the S that goes down like this is easier to connect to the inspection chamber. Are we communicating here? Now, also, there are different types of flush mechanism for your water closet. You have the side flush. You have the top flush. You also have the wall flush. Then you have this sensor type. You might just go to the toilet, you don't need to touch anything, just flash your hand, and the water will just come down. The same thing for even your taps. You know, the days of Ebola, people were thinking, so you have to invent taps that you just flash your hand, and water just comes. And it's even conserved water. It's run for like 30 seconds, it stops. Now, the side flush is a normal WC that you have the flush handle by the side. Is it there? No. This one, we have the top flush. And people don't know. They go to the toilet, you'll see on that top flush, you have 2 buttons. Difficult. You put your hand into and you flush. No. One is actually for high, and the one is for low. You know, if for instance the guy has gone to the toilet and has messed up the toilet and you require high pressure to push whatever you demonstrate there, you use the high one. Then if it's just maybe you went to pee, you don't need to use high one, just use the low one. But they won't do that, they just go, I mean,
So,
if you look at the WC, the two are not they're not flushing. They're not the same height. You know, not the same height. One will be low, will be a bit high. So also the wall flush. When you go to the toilet, it's got that instead of your flush system is placed on the wall.
Even the wall flush too, you have the high and the low for the wall flush. Are we making sense here? Now, let me see if I can still remember these things very well. I hope so. The parts in the WC. Let's see if I can label them. Let's take the tank. The tank is called the system. Then you call it a tank or you call it a system. Same thing. Now, let me start with the style flush. This is called the flush handle. From the flush handle, this place is always open as well, isn't it? That place is called the overflow. This is connected to the ball valve. It's called the ball valve. This is called the lever. Then on it, we have something like this. This is a spring under also. This is called the siphon. Yeah, I'm trying, I'm getting there. Under this, you have a pipe, isn't it? This is called a flush pipe. Now, even this one, there is a back nut there. Then two. Also at this point, to hold this pipe together, you also have another back nut. This pipe is what is connected to the WC, the closet. Then at the bottom here is where you actually connect your pan connector. This is the waste side. What you connect to is called the pan connector. Now, this side that forms like a trap is called the trap, like the S trap or the P trap. What is the function of the trap? That is where I'm going to. Why do you have water retained inside the WC?
Wow, we settle down.
Mango. The waste can only settle down.
I call it design.
It's not design.
It's
odor. That's what I would say. The odor. So you have return of odor. Because we have different types of traps. For your kitchen, you have the bottle trap. For your WC, we said you have the P and the S trap. For your bathtub is the P trap. The shower tray too, you have a trap, the P trap. Even your floor drain, that's a trap. This is just because that you don't allow return of what? Odor. Let me share one small experience with you. I used to work in one M&E company, and we actually had a project in one of these big banks that we had to change all their pipes from galvanized to multi-layer pipes. So the MD traveled one day and he did not use his, for 2 weeks, he did not use his toilet. When he came back, the whole place was smelling. Smelling seriously. They invited a plumber. The plumber just kept chiseling wall looking for leakage. And the empty driver remembered, now I'm in the building. This guy is just chiseling this wall. He's not able to locate where this leakage is coming from. We have an engineer in the house now. They should go and call the engineer. After all, he's an engineer. So I was invited and I said to them, okay, I can solve the problem, but I will take 50K. They, I worked there. How?
I do work there.
I'm telling you the story, so let me finish. I will take 50K. The PA was like, what do you want to do? Which material do you want to buy? I said, which material I want to buy or what I want to do is not for business. You just give me the 50K. If the order is not, resolved, then you can hang me. He said, no, the driver said to him, give him at least half of the money. When you're not convinced, then he return the money back to you. It's in this building, it's not anywhere. So the man gave me 30K. And I said to all of them, excuse me, I will have to lock this toilet and walk inside this toilet alone. So this is every story. I said, It's not for us to resolve the other people I are for. So he said, okay, they left. You know what was the issue? They had a flood drain. And that because in this toilet, there's bedroom and everything. So the flood drain is there. And since we traveled for 2 weeks, there was no water inside that flood drain. The cleaners did not allow water in the flood drain. So there was return of foul hair from that flood drain. And that saturates the toilet. So that is where the odor was coming from. All I did was to buy camphor of 10 naira, put water in the flood drain, because I kept, flushing. After about 1 hour, the odor disappeared. So I stayed there again for another 30 minutes just to convince them that I was busy working. So when they came, they said, what have you done? This place is sad, there's nothing. Engineer, what have you done? So, okay, what I've done is not a problem. Give me my balance money. He said, you didn't do anything, you didn't break anyone. I said, you invited 3 or 4 plumbers, they could not give you solution. And somebody came and gave solution. So that was really angry that he has not done anything. He has used his brain to resolve the issue. It's not everything you use hammer. You use a chisel or pipe to resolve. There are things you use your brain to resolve. That is why we have managers, we have supervisors, and we have technicians. If the manager is on top of his game, once the technicians are not able to solve the problem, and they invite the supervisor is not able to solve the problem, they will call for the manager. So it's expected for the manager to be able to provide solution to the issue. That was how I made 50,000 naira without hammer, chisel, without sweating. And I gave the driver 10,000 naira. And I went away 40K. So the trap in every building, it's very, very important. Very, very important. You need to go around and check if there is, water. When they call as a manager, this place is smelling, this toilet is just smelling. The first thing you look for is to ensure that there's water in the floor drain, the WC has water, the bottle trap under the wash hand basin. Water is retained in it. The secondly,
so what if you have water in the trap and it's smelling?
That's why I said secondly. But I hope you are getting something. Secondly, you have what is called the vents. The vents is actually, if this is a WC, don't mind my drawing, just trying to get something. And you piped it out with there is a T. This is the vent pipe. Now, this one will go into the swell chamber. Now, this vent, if this is your window, and this vent is terminated around here, what do you think will happen? The odor will return from the window back into the bathroom or the toilet. So it's proper that your vent, you take it 0.5 above your window level. So at the final order, you no return back into the bathroom. There are times too, you will enter your toilet, you will press the flush handle. What you have here, you just rise up to fill the toilet. After some time, it will come down. You'll be wondering what is going on. After some time too, you might even flush. It will, fill the toilet, but not go down. It's an indication that your chamber is filled up. Or if it happened when the toilet is on first floor, the indication that there is a blockage along the pipe. So for the blockage, if it's on the first floor, second floor, all you need to do is to get your plunger. Plunge. It will push, the force will push right out on the line to flow back. But if it continues, come back downstairs, open the storage chamber, and check if it's full. So you remove it. Are we communicating? Now, I'm driving this somewhere. Now, we have what is referred to as a single stack system, a separate system, and combined system. Combined stack system or vent system, you want to call it. For the single system, you have your WC on one stack. Your washer basin, you run it on one stack. When it gets to the ground, the chambers too will be separate. The waste, that's the soil, the soil waste will run in one chamber. The wastewater run in one chamber. Then for the separate system, you have these two separated like this. But when it gets to the chamber, it will be combined. I get what I'm saying? Yes, the chamber will combine. But for the combined system, you have a single stack that is taking both the waste and the soil. For this system, you require a plumber that is very good to be able to do this, that you have return order into the building. Now, I'd like to explain something as well. Jesus. You see, if this is the plan of a building, you have a toilet and a bathroom here. You have another toilet and bathroom here. And you have a manhole here. A manhole is simply a hole that can contain a human. It's bigger than the spiral chamber. Now, for waste system, you connect whatever you have here to a chamber. What is referred to as an IC, spiral chamber. And for you to connect to this place, if there's another chamber here, you cannot use elbow. For waste system, you don't use elbow. When you use, this one is a chamber here, you want to connect to another chamber here, you continue to use chambers to link them. You can't use elbow. because if you use elbow, there will be blockage. And also, when you are running your waistline, the slope is always very, very gentle. You don't require sharp slope. The reason is this: if you flush with sharp slope, the thing will just, water will run ahead of whatever is supposed to flush. Whatever is supposed to push. So you need a gentle slope that the pressure can actually equally push what you have along the line. Are we communicating? Are they asking questions? Is it clear? Okay. Now, from this chamber, it's connected to the manhole. I'm going somewhere. From the manhole, it goes to what is referred to as the sewage treatment plant, but the first stage is called the preliminary stage, or some people call it the screen stage. What this means is that you have another bigger chamber here. This bigger chamber, you introduce a screen. This screen will prevent things like pad. Before you know, there are some sewage treatment plants you go to, you see towels. You know, I don't know how those towels get into the system. I don't know. So you need a screen to protect things like that from entering, because there's a pump here entering there. And if the pump is not equipped with grinding components, things like that, if the screen is not there, it will easily burn this pump. That's why you need to put the screen there. Now for this place, it is transferred to the sedimentation tank, which is actually called the primary stage. And this sedimentation tank will inject chemicals like bioenzymes. What the bioenzyme does is that it will introduce this maggots that will now feed on the excreta to decompose it, so that will settle at the bottom. Then from this stage, it will go to the secondary stage. The secondary stage actually is where you have the aeration tank. This tank here is now divided into 3 compartments. At this secondary stage is where you now introduce your blower with your nozzle. So it further breaks down whatever that cannot be broken down here, is broken down here. So it flows like that to the 3rd compartment. And the 3rd compartment here is especially that the water you will get here, it's at least, let's put that 65% pure. Now, from here, it will now go to another tank. But some people will hate their design here. Why some will further increase the design to have another tank, and this tank is referred to as your final stage or tertiary stage. At this point here, you cannot dose your chemical. Chlorine and lime, only chlorine and lime that is used. So from this point, you can actually pump the effluent to an open drain. Some people can decide to go further and say, no, this water, we want to treat it so that they can drink it. So you know that let me tell you one secret. The water they drink in Abuja is actually sewage water. You won't know. Seriously, they treat it and you won't know. Some places you see the water is a bit colored. It's sewage water. Some hotels in Lagos, you think some of them are sewage water, they treat it. I've done one, I won't mention the hotel so that you won't go and start there. So what we do is that after this stage now, instead of sending it to the open drain, we bring in filters. But the truth is that the carbon we use here is actually different from the carbon we talked about. This point, depending on if we can get it, if I get the market, we can actually ask, all these small children, pay them some money. We go and get this battery carbon for you. It's very effective for this. You break it, get a lot of quantity and load it. After this, you can now put your RO system. Put your RO system, to give you very clean water. You won't even know.
So just cover that part.
They are very good carbon.
They're very effective.
No. Don't forget that even when the effects, the RO system will take care of whatever you want to take care of. Question.
So in the sphere of water treatment,
Yeah.
I like how many times you guys it's been categorized because you said based on treatment, the advice from the laboratory.
Basically, we have two types of treatments: the chemical type and the reverse osmosis. Reverse osmosis does not use chemical treatment. It does not. You don't need to inject any chemical. You don't. And the purity level, it's 98 to 100% purity level. WHO standard, World Health Organization standard.
But the basic thing is there are different design.
Yes.
There are different types of design.
It depends on every engineer.
I've seen the situation, the regular filters that they were using bypass like the wash and the filter that it has only one control.
Okay, that is fiberglass. Fiberglass. Yeah. You have the rings and you have the backwash line. It's the same process. It's just reverse whatever is under and it comes to the top.
And let's say that is more good than using the pipes.
I prefer the valves. You know why? In terms of maintenance, if the media you have in the fiber, if they are due for recharge, how do you remove them? You need to lose that valve that is on top. It's called a manifold valve. You need to remove that manifold valve and you start rolling the fiber on the ground for the media to come out. But for the stainless filter, there's a manhole by the side. Just lose the bolt and nuts. You don't think it will come out. If that's your fiber too, if the multi-valve, if it's faulty, it will render the whole fiber useless. But for the stainless, if one valve is bad, you can actually use your spanner to adjust it and it's still working. Less, exactly. So in terms of maintenance, I will go for the stainless. Question. Yeah, different design. Yeah. Like I said, some people will decide to stop here and they'll pump the water from this final stage to the airflow to this. When I'm designing for the sewage treatment plant, 3 parameters you need to consider. You have what is called the COD, you have the BOD, and you have TDS. Lagos State, we always ask you, what is your COD, what's your BOD, what's your TDS? COD is chemical oxygen demand. BOD is biological oxygen demand. And TDS is total dissolved solid. Question? There are no questions.
So I want to test kind of I would like to confirm that this program
The effluent is okay to discharge it on the test.
So it's yes.
Total dissolved solid. So, I think when you come for the field trip, now that you have at least something that you've written down, you can relate it to what you see at the site. So I expect you go through it, then come to the site, you're able to ask questions.
So apart from normal filtration of the sun and water, there are other types of filtration
Of media, you have candles, you have just candles. But candles cannot actually do the type of, in detail, the type of treatment that the media will do. The media in a way is natural treatment. They're not chemicals. Your carbon is not chemical, it's natural. Your sand is natural. It's where you're getting water from. That media is not that somebody just said that, it just looked at the head, how the water come from. You have, if you are sinking your borehole, it will tell you that you go to different aquifer level. You get the place you see the sand samples taken will be different. And so the person sat down and looked at that. Okay, if you go past rocky areas, this you have where the aquifer you have rock. Water from those areas are always very clean. So they looked at that and said, okay, we can actually do this experiment. And the guy did the experiment and said that through that process you can get clean water. You don't even need a filter vessel to actually get clean water. Even if it's an open vessel, open tank, try it, open tank, arrange those things, those media, the way I told you to arrange them, and allow water to flow through it. The water will come out clean. There's this filter they sell in the market. You will see it. It's clear. That filter, they arranged it for you to see. You see the stone, you see the carbon, you see the sand and everything. Small filter. It's not as big as, it's not bigger than this. You see the media. It's not bigger than this. It's just for your spin room. And you just pour your water inside it, it will treat it for you immediately. It's same media that's inside. But this one, I'm saying it's bigger. Those are candles now. Those are filter candles. Even the filter candles, you have different. You have the plain one, you have the carbon one, you have the one that has resin.
So what do you use for pure water?
Pure water. It depends on how pure the water is. The truth is that, like I said, your borehole will determine the kind of treatments you will give to it. Pure water in the island, the way they treat pure water in the island is different from the way they treat pure water in the mainland. Because to an extent, the water in the mainland, it's a bit clean. So the kind of treatment you give to it will not be that expensive compared to the one you do at the highland.
So, they said, even when you can get pure water, you can still actually get wastewater in terms of depth.
Yes, that's why I said aquifer level. You can drill to some extent you have salt water. If you now drill further again, the water will be clean, there will be no salt. So it's aquifer level. It's a strata, different strata. So once you drill, you get to a better aquifer, you get to another aquifer that is muddy, you get another aquifer that has a loose soil, you get another aquifer that has smooth sand, sea soil, just like that.
But is there actually a test before you start drilling?
That is the work of a geologist.
So I tell you that the land is the drink water. People are drilling water. It's a depth they get to. When they get to water and they drink about that depth, you can go beyond the water. You don't water again. So I don't know, to me, I was thinking if you started drilling, in as much as you got to where water level is. So while you are still drilling, the rest should water. But then it's important to drill to. If you get to water, you must stop it. If you drill more, then you might go beyond.
It's not that you might go beyond water. You might go beyond. You might drill and get to a place where you have muddy water. It's not that you won't get water. You still get water. It's not you will drill until you get water.
It's about forward. Initially, the drink the water, bringing out water. And suddenly you just stop.
That's why we talk about yield. No, mention yield now. At every strata or at every aquifer, the well, like, should I use more quantity of water differs. There are places you will drill your borehole, water will be flowing continuously. The yield will be very okay. There are places you will drill, maybe you pump for one day, it's not like it's okay, but the following day, there's no water again. That place, that means before there's no water, the yield is not much. Yes, we are just random. The yield wasn't much. It was just like, let me use the word, I'm going to use this word. It does do boju for you. That is why you need if you're going to do a deep borehole, you actually need the geologist to determine the location where you have good yield, where you could have good yield. Because to drill a deep borehole, for instance, for instance, in Lekki or Aja, to drill a deep borehole costs you a lot of money, between 9, 10, and 11 million. So you want to do trial and error.
Right.
Eh?
9, 10, 11 million.
Yes. Yes, a deep borehole. For a deep borehole.
Because that's one people don't get water. Sand rising.
When it happens like that, if you are getting water before and you now start getting sand, there's a time you say the bore has collapsed.
Anyway.
When you are getting water before, and all of a sudden you start getting sand, mix with water, the bore has collapsed. Thank you very much.
The bungalow, I think you mentioned the bungalow. What's the height of the tank? As in the height of
the height of the bungalow is about 3 meters.
Where you can put the tank that should go.
The height of the bungalow is about 3 meters, worst case scenario 3.2. And so if you want to get good pressure, you can actually do between 3.6 and 3.7. The height of your tank. Yeah. The height of your tank. So, my name is so you can see it. Okay, let me clean my writing already. Yeah. Come on, free me.